Hello everyone. Today we will going to see some practice questions from the chapter General Organic Chemistry. This is part 1. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is our index slide and we will going to see the practice questions from question number 1 to question number 7. Let's start with the question number 1. Electronegativity of carbon atoms depend upon their state of hybridization. In which of the following compounds the carbon marked with asterisk is most electronegative? So basically, we have to find that from the different options we have given, we have marked one carbon atom as a star, and we have to find out that from which option that star carbon is the most electronegative, in which of compound from the option. Options are CH3, CH2 star, CH2, CH3, CH3 star, CH double bond, CH single bond, CH3, CH3, CH2, C triple bond star, CH, or CH3, CH2, CH double bond star, CH. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is CH3, CH2, C triple bond star, CH. So basically, electronegativity of carbon atom depends on the state of their hybridization. More the S character, more is the electronegativity. So basically, the S character and the electronegativity are directly related. If you see the different types of hybridization states, sp, sp2, sp3. The S character in the sp is highest, which is 50%. Then it will be in sp2, which is 33%, and the lowest is in sp3, which is 25% only. Thus, you can say that sp carbon has the highest electronegativity, right? Sp hybridized carbon has highest electronegativity, and you know that sp is observed in triple bond, sp2 is in double bond, and sp3 is observed in single bond. That's why in the option C, CH3, CH2, C triple bond C star. So our star C is triply bonded, connected with the another carbon. That's why this is the correct option, and thus option C is the answer. Okay, let's move on to the next question. Question number 2. Which of the following compounds contain only primary hydrogen atoms? Okay, so basically we have to find out that from the options which compound contain only the primary hydrogen atoms. All the hydrogen atoms should be only primary. Options are isobutene, 2,3-dimethyl but2-ene, cyclohexane, or propyne. You have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see. The correct answer is option B, that is 2,3-dimethyl but2-ene. So basically, 2,3-dimethyl but2-ene contain only the primary hydrogen atoms. If you see the structure of the 2,3-dimethyl but2-ene, you can see this is the primary chain. This is the primary chain. CH3, C double bond, C, CH3. And on the either you start counting from left to right or right to left. The two methyls always come on the number 2 and 3, right? So let's suppose we start from right to left. So 1, 2, 3, 4. So 2 and 3 both are connected to the methyl. So 2, 3 dimethyl, 1, 2, 3, 4. We have primary chain in which 4 number of carbon is present. So we will call it but. Okay. So 2,3-dimethyl but, and the double bond should be in the naming. We use the numbering, the lowest numbering which is coming for the double bond carbon atom. So 2-ene. Okay, so the whole name will be 2,3-dimethyl but 2-ene. And if you see, it only contains the primary hydrogen atoms, because you see all the hydrogen present in this structure is directly attached to the carbon which is singly bonded to the another carbon. In this case, hydrogen is singly bonded to the carbon, which is that carbon is also singly bonded to another carbon. Similarly, in this case, as well as in this case, right? So primary hydrogen atom means who the hydrogen atoms attached to the carbon singly bonded, and then that carbon also attached singly bonded to the another carbon atom. That is the primary hydrogen atom. You can see that in this structure, all the hydrogen atoms are only primary, and thus the B option is the correct answer. Okay, let's move to the next question. Question number 3. The IUPAC name of neopentane is. Okay, we have to tell neopentane is a common name of a compound. We have to tell what will be the IUPAC name of for that. Options are 2-methylbutane, 2,2-dimethylpropane, 2-methylpropane, or 2,2-dimethylbutane. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option B, that is 2,2-dimethylpropane. So the neopentane structure is this structure. We call it as neopentane as a common name. The common name of this structure is neopentane. The IUPAC name, if you find out, we have to follow some rules. So first we have to identify the parent chain. So you can see if you go from 1, 2, 3, 1, 2, 3, anyway, only three number of carbons can be there in our primary chain, right? Here also 1, 2, 3. 1, 2, 3. Only 3 carbons are possible. So we take this horizontal chain as our parent chain. So on the 2 position, 1 carbon is present to which 2 methyl groups are attached, right? So its name will be 2, 2. At 2 position, 2 times methyl group is coming. So 2, 2 dia for 2 methyl, 2, 2 dimethyl propane, because in the parent chain 3 carbon are present. So we use prop for that. So propane, because no double bond or triple bond is present, so we use ane, and that's why the IUPAC name will be 2,2-dimethyl propane. Okay, so the compound having common name neopentane will be having the IUPAC name is 2,2-dimethyl propane, and thus B option is the correct answer. Okay, let's move to the next question. Question number 4. The IUPAC name of compound shown below is. We have given a compound here. You can see the structure. We have to find out the IUPAC name for this compound. Options are 2-bromo 6-chlorocyclohex-1-ene, 6-bromo 2-chlorocyclohexene, 3-bromo 1-chlorocyclohexene, or 1-bromo 3-chlorocyclohexene. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option C, that is 3-bromo 1-chlorocyclohexene. This is the structure, right? We just draw it in a same, not in a same way, but a bit different. Like we have a 6 carbon chain, we have a 6 carbon chain. Okay, we have a double bond somewhere, so we put double bond here, and the double bond carbon is directly attached to the chlorine, so we attach chlorine here, and the second double bond carbon, after that one carbon will be directly attached to bromine, and same is here. Okay, so they both are same structure. Now what we do, we just number. So we number the carbons, and on the basis of rules, the unsaturation, that is double bond, is at priority over the halogen. Okay, so if you prioritize the double bond carbon, then the one number will come here, right? Because the lowest number should be come at the carbon, at the carbon double bonded carbon. Okay, so 1, 2, 3, 4, 5, 6, and double bond is prioritized over halogen. So no matter whatever the number is coming on halogens, we have to put the lowest value, lowest number on the double bonded carbons. So the correct IUPAC name will be 3 bromo, 1 cyclo, 1 chloro, cyclohexene. Okay, because hexene, why? We can write it as hex 1e, but hexene we can also write because on the first carbon the double bond is coming, right? C1 and C2 at the position first, and at the position 2 double bond is present between these two carbons, and we put the lowest number in the naming. So we put 1, and either you can write 1 or you can just write hexene. Okay, so so the correct IUPAC name for the given compound will be 3 bromo 1 chloro cyclohexene. Okay, naming will be alphabetically. So B will come first, C will come later. That's why 3 bromo 1 chloro cyclohexene. And thus C option is the correct answer. Okay, let's see the next question. Question number 5. Which of the following compounds represents 2,2,3 trimethylhexane? We have given some direct chain structures, and you have to find out that which structure is representing this formula, which is 2,2,3 trimethylhexane. Options are CH3C, CH3 whole twice, CH2, CH2, CH, CH3 whole twice. CH3C, CH3 whole twice, CH2, CH, CH3 whole twice, CH2, CH3, CH3C, CH3 whole twice, CH, CH3, CH2, CH2, CH3, or CH3C, CH3 whole twice, CH2C, CH3 whole twice, CH. So you have to tell the one option which is correct, which is matching this name given in the question. You have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see. The correct answer is option C, that is CH3C, CH3 whole twice, CH, CH3, CH2, CH2, CH. Right? So if you write the 2,2,3 trimethylhexane formula, it will be represented by this structure. Okay. Basically, we have given hexane. That means in our parent chain, 6 number of carbon atoms should be present. So we just write carbons. Okay. On the 2 position, again on the 2 position, and on the 3 position, methyl groups are present 3 times. Tri is used because, right? Because once at 2, again add 2, and then add 3. So we just put that. Add 2, we just put CH3 and CH3, and at third position also we attach the CH3 group, and this will be our final structure. 2, 2, 3 trimethyl-hexane. No double bond or triple bond is present. Okay, then we just match this from this chain. So it will be CH3C, C and CH3 whole twice. That means this CH3 whole twice is attached to this C. Okay, this carbon. And then CH and bracket CH3. That means this CH3 in the bracket is directly attached to this carbon. Then CH2, CH2, CH3. This is simple chain. Okay. Thus, our C option is the correct answer. That means it correctly represents this 2,2,3 trimethylhexane naming. Okay. Let's move to the next question. Question number 6. The structural formula of 2-oxo 3-methyl N-bromobutanamide is. Again, we have given a name and we have to find out the structural formula of that particular name. Options are, you can see the first structure, CH3, CH2, CO, CO, NHBr, CH3, CH, CH3, CO, CO, NHBr, CH3, CH2, CO, CO, N, CH3, OBr, CH3C, CH3 whole twice, CO, CO, NHBr. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option B, that is this structure, CH3, CH, CH3, CO, CO, NH, Br. Okay, so we can easily name it as 2-oxo-3-methyl N-bromobutanamide. How? Let's see. So we just number the first. Okay, first of all, we number our parent chain, starting from the carbon, because this is the side chain, amide group, right? Bromomide, you can say. So first add this carbon, then second carbon, then third carbon, then fourth carbon. Maximum number of carbons a parent chain can have, okay, in this structure. Then at the 2 position, we have oxo. So at the 2 position, we have oxo, right? This is oxo. At the 3rd position, we have methyl, right? At the 3rd position. And then N-bromo, we have bromo, that means bromine at the N, ammonia, and then butanamide. Buta means we are using this for the 4 number of carbon atoms in a chain. So butanamide. Okay, amide because NH group is present. So we call this functional group as amide. Right? Thus, for this name, 2-oxo-3-methyl N-bromobutanamide, this is the correct structure. And thus option B is the correct answer. Okay. Let's move on to the next question. Question number 7. The maximum number of isomer for an alkene with the molecular formula C4H8. So basically, if you have a molecular formula C4H8, which is an alkene, so what will be the maximum number of isomer it can have? Isomers are basically structures, you can say, molecular structures, which are different structurally, but molecular formula of them will be same. Right? We just arrange some groups along a double bond differently in both the structures, but overall the molecular formula will be same for both the structures. That are known as isomers. The maximum number of isomer which can have for this alkene having a molecular formula of C4H8 is. Options are 2, 3, 4, 5. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. So the correct answer is option C, that is 4. The maximum number of isomer for an alkene with the molecular formula C4H8 is 4. How? Let's see. First one is this simple, which is but1ene, you can name, right? Like simply write the structure and put a double bond at the first position. That is but1ene. This is first isomer. Then second will be, you can put this double bond in between these two and second and third carbon, right? So if we put this, then at first carbon, 1 methyl and 1 hydrogen group will be there. At second carbon, similarly, 1 methyl and 1 hydrogen group will be there. And you can rearrange that. Like you can put these 2 methyl groups at the same side and at the different sides. Right? If you put the methyl group at the same sides of the double bond, then it will be cis-but2ene. And if you put the methyl groups at different side of the double bond carbon, then it will be called as trans-but2ene. 2ene because at the second position of carbon, or you can say at the carbon having the second position is having double bond, right? So we put the lowest number here, so we put but2ene. Because double bond is present between second and third carbon, but we put 2 in the naming because we use the lowest number. And the fourth isomer will be this. You can rearrange the structure as like this also, that C having 2 methyl group attached to it, double bond CH. You can count here that number of carbon is 4 here, and the hydrogen will be 8. 3 plus 3 is 6, 7, 8. Right? So it is the 4 of these isomers is having the same molecular formula basically, which is C4H8. You count the number of carbon and hydrogen, it will be 4 and 8 respectively in all these 4 isomers. But they are different structurally, right? That's why they are known as isomers of each other. And you can see that a molecular formula, an alkene having a molecular formula of C4H8 having maximum number of isomer as 4. Okay, and that's why we have C option is the correct answer. Okay, thank you.